Alright, the actual homework for 5-6 and not the ACT stuff. So it should start right here. I'm doing these so that you can actually see how to do the ones underneath them, because they're very similar. So find the inverse of f of x, and writing an inverse is actually really easy. All we're going to do is we're going to swap x and y, and then we're going to maybe resolve. You know what? This just isn't working. I'll type that. I'm going to swap x and y and resolve for y. So here's my equation that f of x is going to become an x, and then I've got my negative 1/2 that x is going to become a y plus 5. I'm going to subtract 5 from both sides. Why not? And to counteract this whole negative 1/2, I'm going to take both sides and multiply it by negative 2. And that's going to give me 2x minus plus 10 on the left, and negative 2 times negative 1/2 is y. Finally, I'm going to use the correct notation, the inverse of f of x. So, the next job is to show that f and the equation you wrote are inverses. So, the deal on this is if f of its inverse returns the identity function x, and the inverse composed of f of x returns the identity function x, the two are inverses. So let's plug the inverse into the original one. So I'm up here, I'm scanning this guy right here. There's a negative 1/2, there's the x. I'm going to replace that with 2x plus 10. And then the original function says, if you just follow my cursor right there, add 5. If I distribute the negative 1/2, a negative half of 2x is negative x, and a negative half, I made a mistake back here, didn't I? Negative 2x. Negative 2x. There we go. Negative 2x. A negative half of negative 2x is positive x, and a negative half of a positive 10 is negative 5, and then there's that little plus 5 right there, and it equals x. So I'm halfway there. Now what we'll do is we'll look at what happens when I compose the inverse from the original function. So I'm going to find this second part right here. So the inverse starts with a negative 2. There's an x, and that x is going to become this guy up here. Negative 1/2 x plus 5. And then the inverse says add 10. So a negative 2 times a negative half is a positive 1, so there's my x. And a negative 2 times 5 is minus 10, but then there's this plus 10, and this equals x. So, what have I learned? I have learned that by composition, two functions are inverses. That's what I just learned. So if you don't know how to do the ones underneath, you're looking at this stuff. 4 is sketch a graph of f and its inverse. And also the equation y equals x so that you can see the symmetry. And here's where it's going to be fun because my sketchpad is giving me so many issues. But let's try it anyways. My memory's right, that was the inverse. I need to hurry up and do it. Otherwise, I'd be making some mistakes. Now, every junior should know how to draw a line. That's not necessarily true. Right now, I am looking at this function right here. It crosses at 5. And its slope is to fall 1 and run 2. 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 It should cross the x-axis at 10. It should. So there's f of x. And its inverse is negative 2x plus 10. Anyways, that's going to be 10 units higher. Do that in a different color. It's going to fall 2 and run 1. It's going to fall 2 and run 1. And it should evidently cross from round 5, 3, 4, 5. If we keep falling 2 and running 1, we're going to end up right here. And there is the inverse. Now, you may not realize that these are actually inverses until you draw in the line y equals x, because that's your symmetry line. Y equals x crosses at the origin, it rises 1 and runs 1, and it should pass right through that intersection. It usually does. Maybe now, for some of you, you can see the symmetry of what you've drawn. But if two functions are inverses, they are by definition symmetrical with y equals x. That's why you do it. I'm just going to write that down for y'all. If two functions are inverses, they are also symmetrical with the equation y equals x. The identity function. So, here we go. Is the inverse of f of x also a function? The answer to that is yes, it is a function. I know it's a function because it passes, and this is something that needs to be talked about. Hopefully I did it in class when I taught the section. It is a function. It passes the vertical line test. The inverse was the blue line there. And anywhere on that blue line, I could draw a vertical line, and it only touches it one time. Doesn't matter where it goes. So it's definitely a function because it passes the vertical line test. So there you go. All right, what are we looking at here? 12, and then I'll probably do 2 more of these. Find the x and y intercepts of the function y equals 2x plus 1. What are the intercepts of the inverse function and how are they related? So you've got to do some more stuff here, unless you know the shortcuts, but whatever, we'll just do them. So let's talk about our x-intercepts. We let y equal 0. 0 equals 2x plus 1. If I slide and divide, I have an x-intercept at negative 1/2. And let me use ordered pairs. -1/2, and the y value is 0. To find a y-intercept, I let x equal 0. So y is 2 times 0, add 1. So the y-intercept is 2. And the ordered pair here was 0, 2. Now, this thing also wants to know the intercepts of the inverse function. So I'm going to write the inverse function. X is 2y plus 1. I'm going to subtract that 1. X minus 1 equals 2y. Divide by 2. And use the correct notation. Cool, there's my inverse function. Now I'm going to find the x-intercept again with the same thing as I did earlier. I'm going to let y equal 0. So 0 equals x over 2 minus 1/2. Shift my half to the right. Double both sides. And x is 1. I was expecting something different. Oh, because I screwed up here. That's why. 2 times 0 is not 2, it's 0. Add 1, you get 1. So notice that the x-intercept and the y-intercept have changed places. All right. I fully expect the y-intercept of the inverse to be -1/2. All right, time for the y-intercept here. Again, we let x equal 0. So I'm looking at this equation right here. That becomes 0 over 2 minus 1/2 is y. And ta-da, the y-intercept is -1/2 with an ordered pair of 0, -1/2. So look what happened. They swapped places. Why did they swap places? The x and y intercepts swapped because inverses swap domain, which we generally consider to be x, and range, which we consider to be y. That's why that happened. It will always happen. That's how it works. Let's see, what are we supposed to do on this next group? We are supposed to find the inverse of the function and state the domain of the inverse. That's a big deal. That's a really big deal. 2x squared minus 5, and you might have to look at it on a graphing calculator. I don't know. If I pull up my graphing calculator, though, this program I'm using to record video just goes to crap. But 2x squared minus 5 crosses at -5, and then it's a parabola. Looks like that. If you don't know that, that's part of the issue. You're not learning. You're not trying to learn the content. So you just keep creating this wall of trouble that gets bigger and bigger and bigger. And what I'm going to do is I'm going to throw away all of that. I should have used the eraser there. I'm going to throw away this right here. It's gone. All right. So what I'm saying is I'm saying that x has to be greater than or equal to 0. All values of x such that x is greater than or equal to 0. This is a hard concept for some people to get. You see kids show up in pre-calculus and they don't understand domain. You're already in trouble. You better hurry up and figure out domain. So there's going to be my domain. That's not too hard to do. Now I'm going to start writing the inverse. And to write an inverse, you swap x and y, and then you resolve for y. So that f of x becomes an x, and that x becomes a y, and then I just go to town on this thing. It's not hard. Solve it for y, I'm going to add my 5. I'm going to divide by 2. I'm typing this, so that's why it looks like that. And now I'm going to counteract my square with a square root. And that's sadly not something I can draw on this program. Now, just because I kind of want to check it, and I don't want to spend some time on composition, I want to show you their inverses. So I'm going to good old Desmos. I like Desmos. Be cool if you did. The original equation was 2x to the second minus 5. And I'm going to try and put a domain restriction on here. That's evidently not how you do it in Desmos. Maybe it's parentheses. No. I've forgotten how to do this. Let me pause the video so I'm not wasting your time. Sorry, took me a second. You use curly braces in Desmos, and that's it. You don't use the all values of x such that. And technically, it's the greater than or equal to symbol. There you go. Now, the function that we wrote should have been the square root of x plus 5 over 2. Should have been. Square root of x plus 5 over 2. There she is. And if they are symmetrical, they're symmetrical with the identity function, y equals x. And look, they are. So you got this point right here at 0, negative 5, and it became negative 5, 0. You're crossing the line of symmetry, and you can just see it. So they're symmetrical to each other. All right, I'm only going to do one more, and that's number 16. The only other one I can do on your homework. And 16 is a special factoring pattern, which is what enables you to do this. So I'm going to factor it first. It factors as x minus 3 times x minus 3, which is the same as x minus 3 to the second. You know, if you understand factoring, you can see that I factored it. Factoring is always something I'm thinking about. Now that I've written it like that, I actually can write the inverse. So let's swap the x and y. We'll resolve. We counteract the square right here by a square root. Let me put that little symbol there. And then I add 3. So I get root x plus 3 is my inverse of f of x. By the way, I forgot to do that up here too. Now, that's what she looks like. You talk about her domain. Her domain, or his, or they, or their, or whatever it is, this inverse's domain is inherited from here. Whenever I factored this as x minus 3 times x minus 3, I actually learned what it looks like. It simply goes right 3, because remember vertex form? Right 3, up nothing, and then it's a parabola. And I don't want to keep the full parabola because the full parabola fails the horizontal line test. So I only keep that piece. That's all I'm keeping. So my domain restriction here is all values of x such that x is greater than or equal to 3. And I'm done. And that's all the homework of yours I'm doing. I hope it was enough. I hope you're doing your homework.